On July 16, 1945, at exactly 5:29 in the morning, the New Mexico desert turned into the surface of the sun. The shockwave shattered windows 120 miles away. Sand melted into glass, and the scientists watching from a distance fell completely silent. They had just detonated the most dangerous substance ever created by human hands. Not uranium, not a chemical explosive, plutonium, a metal so radioactive that a single invisible speck can give you lung cancer, a metal that actually changes shape sitting on a shelf, a metal that barely exists on this earth. So how did we create it? How did it become our most powerful weapon and our most powerful energy source? Stay with me, because this story goes deeper than you think. A metal that shouldn't exist. Here is something most people never learn in school. Plutonium does not naturally exist on Earth, at least not in any meaningful quantity. Billions of years ago, when a massive star exploded in a supernova, the shockwave was so violent it fused atoms together that had never been fused before. That process created plutonium. But plutonium decays fast. By the time our solar system formed 4.5 billion years ago, almost every plutonium atom had already disintegrated. Today, Earth's crust contains only 1 part per trillion. Basically nothing. So when scientists in 1940 wanted to study it, they had no choice. They had to make it themselves. And what they discovered when they finally created it shocked everyone in the room. How plutonium is made. To make plutonium, you need a nuclear reactor. Inside the reactor, uranium fuel rods are bombarded with neutrons. And most uranium atoms split apart and release energy. That is what powers the reactor. But some uranium atoms do something different. Instead of splitting, they absorb the neutron. And that single absorption transforms them into an entirely new element. Plutonium-239. After months inside the reactor, the fuel rods are removed. They are now so radioactive they would kill a person standing 1 meter away in minutes. These rods go into deep, cooling pools, that glowing blue water you have probably seen in photos. Then technicians, working entirely by remote control behind thick lead glass, dissolve the rods in acid and chemically extract the plutonium. What comes out is first a paste, then a powder, then under extreme pressure, a metal. The strangest metal in the world. Most metals follow simple rules. Heat them and they expand. Cool them and they contract. Plutonium refuses to follow any rules. It has 6 different solid phases, 6 different internal structures that it shifts between as temperature changes. This means a block of plutonium sitting on a workbench is physically changing shape on its own, expanding, contracting, warping, and cracking. One of its phases actually shrinks when heated, which is the opposite of almost every other material on Earth. It also generates its own warmth because it is constantly radioactively decaying. Billions of particles shooting through the metal every single second. This is why machining plutonium is one of the most dangerous jobs on Earth. The cutting tools create fine, invisible dust. If even a tiny amount is inhaled, it embeds in your lungs and stays there for the rest of your life, however long that may be. The Fat Man, August 9th, 1945. A bomber flew over the Japanese city of Nagasaki, carrying a single weapon nicknamed Fat Man. At its core was a sphere of plutonium, roughly the size of a grapefruit, less than 6 kilograms. When precisely timed explosives compressed that sphere from all sides within microseconds of each other, the plutonium went supercritical. A chain reaction ignited. In less than 1 microsecond, the energy released equaled 21,000 tons of TNT. 40,000 people died instantly. Nagasaki was erased from the map. That grapefruit-sized piece of metal changed the course of human history forever. Plutonium in space. But here is what most people never connect. That same metal, the one that leveled Nagasaki, is also what powers some of our greatest achievements in space exploration. In 1977, NASA launched Voyager 1 and Voyager 2. They are now beyond our solar system, further from Earth than anything humans have ever built, and they are still sending data back today, powered by plutonium. The system is called an RTG. Plutonium-238 decays naturally and generates heat. That heat is converted directly into electricity with no moving parts, no solar panels, and no fuel that runs out. Just the slow radioactive heartbeat of plutonium ticking away for decades. The Mars Curiosity rover runs on one. The New Horizons probe that flew past Pluto runs on one. And for about a decade in the 1970s, some cardiac pacemakers implanted inside human hearts ran on one too, beating quietly in people's chests, powered by the same element that ended World War II. The danger right now. There are approximately 500 metric tons of separated plutonium sitting in secure facilities across the United States, Russia, the United Kingdom, France, and Japan. The International Atomic Energy Agency tracks every single gram. The reason is simple. It only takes 8 kilograms of plutonium to build a nuclear weapon. 8 kilograms. The weight of a laptop. In 1994, German police caught smugglers at Munich airport carrying 363 grams of plutonium on a commercial flight, brought from Russia. Not enough for a bomb, but enough to prove that moving it is possible. This is why plutonium is the most tightly controlled substance in all of human history. More than any drug, more than any chemical weapon. Because the scientists who created it understood something they could never escape. They could not uncreate it. Plutonium is proof that human knowledge cuts both ways. The same physics that lets us explore the edge of our solar system also gave us the power to erase cities. The same metal that beats silently inside a spacecraft was shaped into a weapon that ended hundreds of thousands of lives in an instant. It is not evil. It has no intention. It is simply the most powerful and most unforgiving element we have ever touched. Plutonium does not care about politics, borders, or human decisions. It just decays slowly for the next 24,000 years. The question was never whether we could create it. The question we are still answering today is whether we are wise enough to control it. If this video made you think, hit that like button. It genuinely helps the channel grow. And if you want to know about the most radioactive places on Earth that still exist today, that video is coming next. Subscribe so you don't miss it.